Okay, welcome. Welcome back to one of these videos where I try to explain why a certain number is cool, as the kids say. In this video, we will be discussing why the number the number 26 is cool. Wait, actually, I wanted to write this in a question form. Well, okay, you know what? It's okay. I'm just gonna write exclamation mark. Okay? Exclamation mark. And also, I just want you to notice that I'm actually standing. So I'm actually standing. You can see you can see my pants, my pants. Um, Thankfully I was wearing pants. Yeah, okay. And the reason why I'm standing is because last time I was sitting. And the time before, I was also sitting. And so I told myself, how can I make these videos more exciting? And how can I get more videos? Not more videos, more views. And definitely the answer is going to be the fact that standing makes people want to watch you more than when you're sitting. Okay. So this is the logic. So you see my chair? My chair is over here. This is the chair. This is the chair. So I was in high school. I was called sometimes. I'm debating whether I should tell the story. You know what? Let's save the story for some other time. 27 minutes. Okay. You try to think of you try as a homework assignment. Try to think of how my name could have been associated with a chair. So that's a chair. And the hint is that you need to use a language other than English. All right. Now, to get back to the actual point of this video, the point of this video is to understand and to really master. No one's mastering anything in these videos. Master why the number 26 is so special. And so the first thing I wanna show you is that 26 it's prime factorization. And remember, prime factorizations are unique. Prime factorization is 2 times 13. 2 times 13 is 26. 26 is also the number of letters in English. Well, in the English alphabet. Okay. And people who are very Anglo-centric, they think that means that all alphabets have 26 letters. In fact, this is very false. Some languages don't even use alphabets in the standard way we think about them. But languages that also use the same kind of alphabet type as English don't have the same number of letters in them. For instance, in Italian, which is a language that I pride myself in, roughly speaking. There are 21 letters. So this is not a video about 21, but it's just to let you know that in Italian, there's 21 letters. And the reason why is because in Italian, we gut some of the letters, namely a J. So JK, I'm not joking. I'm just saying this is the first, those are the first two letters that we ditch, J and K. You never actually need to use J in Italian. Most of the time, a GG suffices. K, the K sound, the K, that normally comes from CH. There's also the W sound. The W sound is just never W. You never say that in Italian. Don't if an Italian somehow says something like um, something using the W sound. There's no real W sound, but you don't need the W. Is what I'm saying. And then X. That's so a very common mistake is many people think that espresso is expresso. And this is false. This is not true. There's an X on the X because it's double X bad. Okay. And then the final letter that is not a letter in Italian is Why? Because you don't need that either. I had some good reasons for why I didn't need the first two. And then to be honest, the other three, it's just I can't really think of any examples. One, and also yeah, it doesn't. Maybe I'll cut this part out. I probably won't because I don't really edit these. But anyways. Okay, so that's some of the reasons why some of the reasons why 26 is interesting. I feel like I've lost you, but I also feel like I've lost myself. So in that sense, we're both winners. Now, the real reason 26 is a cool number and why I'm excited about it and why I'm standing for it um, is because, like I was saying, the prime factorization of 26 is 2 times 13. And so if we take these three numbers, okay, 2 times 13, we're going to be able to do something with some maths with only these three numbers. So what I'm going to do to use these three numbers is I'm going to start with a very basic fact from mathematics. You might have heard about this fact in Calculus 1, 2, other calculi classes, and other mathematical classes. Maybe also other classes that discuss other things, but probably not. And so this mathematical fact is related to this sum, this geometric series, which has this very special form where you take increasing powers of the same number x, so increasing powers of the same number x from the 0th power, so starting with x to the 0, all the way to infinity. So this is an infinite sum. So for instance, if x was 2, let's say, then the series would start out as 2 to the 0 plus 2 to the 1 plus 2 to the 2, and so on. Okay? So this series is infinite. It has an infinite number of terms. And the fact, though, so this is just a series. I haven't told you the fact. But the fact that's very special about the geometric series is that whenever you have a real number where its absolute value is bounded by 1, then the geometric series, even though it has an infinite number of terms, it converges to a single number, a single sum, meaning that the series in sort of a high level sense has a limit. Okay, it has a point towards where all of the terms sum together accumulate to. Okay, and that converged sum has a closed form solution, which is pretty amazing. It has a closed form solution, meaning that we have a formula for it when the absolute value is bounded by 1. Well, in fact, when the absolute value isn't bounded by 1, then the series diverges. Okay. And so in this case, the closed form solution for the geometric series when it converges is this very dainty looking equation, 1 over 1 minus x. So what this means is that if I took, x is equal to a half, and I started summing a half to the 0, plus a half to the 1, so really this is 1, and then this is a half, and then a half square, so that's a fourth, and so on. So if I summed all these elements together as we went to infinity, then the value of this infinite sum would be 1 over 1 minus a half, which would just be 2. Okay, and that's pretty cool. But that's not what 26 has nothing to do with this, right? So that I could show you the proof. I won't because I've already wasted enough of your time. And if you're still by some miracle watching me drink this oat milk, then I really have to move things forward. Okay. Okay. So what does 26 have to do with the geometric series? So what I'm going to do here, I'm going to take the geometric series and its closed form solution. So I'm going to take this guy, copy, paste, okay? I'm going to take this guy, and so this is an equation, right? It has a left-hand side, it has a right-hand side, and the equality symbol is saying that these two things, these two terms are exactly equal to each other numerically, right? In terms of the real numbers. So what I'm going to do is I'm going to take one of the numbers in the prime factorization of 26. I'm going to take 3, and I'm going to use 3 as the rule to do something. So what I'm going to do is I'm going to derive this equation. So I'm going to take the derivative with respect to x on both sides, okay? And I'm going to then multiply that. I'm going to then multiply that. I'm going to multiply the result by x, okay? And I'm going to do that 3 times, okay? I'm going to do that 3 times, hence using the 3 in the prime factorization, and I'm going to get to somewhere that's going to be interesting, okay? So now, you guessed it, you're going to have to watch me compute through derivatives. So let me try to do this as fast as possible with as few errors as possible. So I take the derivative on both sides. Here I get n times x to the n minus 1. And on the right-hand side, I get 1 over 1 minus x square. Is that right? Yes, that's right. Okay, so now I've taken my derivative, and now I'm going to multiply both sides by x. So on the left-hand side, I'm going to get n times x to the n. And on the right-hand side, I'm going to add x over 1 minus x squared. Okay. Now, again, I'm going to take the derivative on both sides. I'm going to take the derivative with respect to x on both sides. On the left-hand side, it's going to be straightforward. It's going to be n squared and to the x to the n minus 1. On the right-hand side, it's going to be less straightforward. So I'm going to have to do it on the margin of the page. I'm going to do it this way, how calculus teachers like to do it when they don't have time to do anything because they're stressed and their life has no meaning. I'm just kidding. The calculus teachers are very important, like I was just saying before, or maybe that was a previous video. Um, yeah, I don't know. I'm riffing here. I'm riffing. I'm also okay. 2 1 minus x. I really hope I didn't make a mistake here. Oh, I forgot to carry x. 2x. 1. Wait, why did I put? Okay, that didn't make any sense. What I just did there. It should just be 2x here. Okay. And then it's 1 minus, oh dear God, x plus 2. I should just use the quotient rule. Why the hell did I do this? Just use the quotient rule, calculus teachers. Okay, I thought it would look cool by doing this, but okay. So this is the result you get on the right-hand side, and I'm fairly certain it's correct. If it's not, then I'm screwed and this trick is not going to work. So let's hope that I didn't screw up. Okay, so then I get an equals 1 plus x, and then minus x cubed. I'm stressed. My heart's pounding because I don't know if I made a mistake, and I don't want to check because I don't want to waste your time. Okay, so let's do again. So so this is round 2. I'm going to multiply by x on both sides. I'm going to get on the left-hand side n square x to the n, and then on the right-hand side x 1 plus x 1 minus x cube. Okay, and again, this is a 3 of 3 now. I'm going to slap the derivative on both sides. I'm going to derive with respect to x, ddx on both sides. So again, left-hand side, fairly straightforward. N cube, x to n minus 1. Okay, right-hand side, right-hand side. Let's use the quotient rule. So quotient rule means I have to derive the chop So that'll be derivative of x is 1, so then 1 plus x, derivative of 1 plus x is 1 x, and then I'll do this, and then it's a negative, and then I'll do this, and then I'll do this, and then it's 3 1 minus x squared, and then minus 1. Oh dear God, I really hope this is right. Okay. 2x 1, 1 minus x cubed, 3x plus x, 1 minus x square, 1 minus x power 6. Okay, so before I do the canceling, I'm gonna have another sip of my oat milk. This oat milk is brought to you by the oat milk company, and it's very good. Right. And you know, while I'm at it, I'm gonna have some of these nuts. These nuts are also brought to you by nut company, and they're also very good. Is there anything I can make a story out of? No, I don't think so. Okay. I think it's the fact that I'm standing. It's really changed the dynamic. It's made me make a lot less serious comments. I really apologize for this. Next time, I will go back to sitting. Even though I'll get so many more views this time, I'm gonna go back to sitting. Okay. So, what was I doing here? Yeah, I was gonna cancel. Okay. So cancel here. This is a 4. This is a 1. So now I get this. I get 3x, 1 plus x. And then I get this on the bottom. And then if I multiply everything, it's 3x squared, 1 minus x to the 4. Let's see, 5. I think this is right. Yeah, x squared plus, damn, did I know? Wow, I didn't make a mistake. I mean, of course I didn't make a mistake. How am I, how could I be a PhD student as a university? Okay, excellent. So this is the answer that I was looking for. I'm glad I found it. So this is the, remember, I was doing, remember, 26 is 2 times 13. I use the 3 to do this 3 times. Make a story out of it. Okay, so I get this. And now I'm going to apply the final operation on both sides. I'm going to multiply by x. So the final equation, equality, equal, I'll get is this bad boy. Okay, this bad boy here. Okay, excellent. So now you're probably still thinking, what the hell does this have to do with 26, man? So remember 26, like I said a few times already, 2 times 13. I use the 3 here, so I could still use the 1 and the 2. What I'm going to do is I'm going to take 1 and divide it by 2. So I have a half. Okay. And I'm going to take x and I'm going to set it to a half. So what that means on the top, or no, sorry, what that means on the left-hand side is the series I've created, S26, I'll call that S26, the series 26. It's going to be the series that looks like n cubed times 1 over 2 to the n, or really it's just a bunch of cubic numbers, each divided by powers of 2, right? So what this sum looks like, it's, well, you get a 0 here, so that's not really interesting. But then you get 1 cube over 2 to the 1, and then you get 2 cube over 2 to the 2, and then you get 3 cubed over 2 to the 3. So this is quite a nice series, a nice looking series. 4 cubed over 4 to the 3. No, that's definitely not it. Okay, so you keep going. Okay, so this is a beautiful looking series. And turns out now we have an equality, right? So this is an equation. And so it'll be valid for any x with absolute value less than 1, right? Because that's what we started with. That was the assumption we started with here, right? Where is my laser? We started with this assumption here for this guy. And then we just, we did some math, bunch of computation. Math is awesome. Thank you very much, math. And now we got here, right? So this is where we got. Okay, it's an equality, right? Equalities mean things are equal. Oh God. Equalities they mean things are equal. Okay? So that's excellent. So that means I can take this solution here for this term. Oh, no, don't cut it. No, don't cut me away. Don't cut me away, man. Okay, and I can plug in x a half. I can get it. Okay, there we go. Let's plug in x a half. Oh, yes. If you want to watch me plug in x a half here, then you're going to watch me do the computation. I mean, if you're still here, then just wait a few seconds. Okay, wait a few seconds. Here, so watch this. Watch this. I'm Pierre Trudeau. Watch this. Or watch me. He said watch me. So plugging in, doing a standard thing. See here, this is nice because I can just talk. I can just talk to you. Okay, I can no longer talk to you. I actually have to compute. Okay, so let's do this. So half times a half squared is, that's right, very good, a quarter. And then plus 4 over 2 is, yeah, that's right, it's 2 plus 1. And then I'm going to divide 1 minus a half, very good, to the 4th power. 1 over 16, that's right, ladies and gentlemen. 1 over 16. Now you take this 1 over 16, you take this 1 over half, you do gymnastics, right? Gymnastics. And you get an 8, right? So hopefully you saw that. And then you get the 3 and a quarter. 3 becomes total of 4. Then you get 13 over 4, more magic. 13 over 4. Oh! 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 You take the 4, you get to the 8. You get 2 times 13. You get 26. 26. We got 26, and that's why 26 is cool. Thank you very much. Have a nice weekend.